Good morning, students. Students, this lesson is of class 9th for the subject of physics, and the topic for today is numericals based on lens formula, which is covered in chapter 5, that is refraction through a lens, and is given on page number 122 of your physics textbook. Students, before starting numericals, first let us learn the sign convention in the measurement of distances, as you can see in figure number 1. So students, kindly see figure number 1 drawn on page number 1 of the notes submit to you on 14 December 2020. So now students, in figure number 1, you can see a convex lens, and we will take optical center as the origin taken in a graph, such that all the distances has to be taken through optical center, and the distance towards right side will be taken as positive. Since it is positive x-axis, so the distances along right side of the optical center will be taken as positive, while the distances on the negative side will be taken as negative. The side left to the optical center, the distances has to be taken negative, since it acts as a negative x-axis. Similarly, the distances above the optical center towards upward will be taken positive, and downward will be taken negative, as we consider positive y-axis and negative y-axis towards upward and downward direction. Student sign convention were done in class 8th also in mirrors formula. So the sign convention is still the same. But then coming to the lens formula, the formula for calculation the dimensions of lens is 1 by V minus 1 by U is equal to 1 by F. Now the question comes, what is V, U and F? Students, V stands for distance between lens and the image. U is the distance between lens and the object. And F is focal length of the lens. Students, kindly be cautious, because in case of mirror, we have done formula as 1 by V plus 1 by U equal to 1 by F. There, in mirror formula, you are having 1 by V plus 1 by U equal to 1 by F. But in case of lens formula, it is 1 divided by V minus 1 by U equal to 1 upon F. So here you are having a sign of negative. 1 by V is getting subtracted. So students, just be cautious about the formula over here. Focal length, student, have to be taken, F, U and V have to be taken through optical center only. Since we have considered in the chapter the lens to be thin, thus all the distances which are taken from the lens are basically taken from the optical center of the lens. So students, for convex lens, focal length is taken to be positive, as it lies on right side of the optical center. Students, in case of lens, as we have discussed last week, focal length has to be taken between optical center and second focus. Not the first focus, second focus. So in case of convex lens, Second focus lies on right side, while in case of a concave lens, which we did last week, the second focus was lying on the left side of the lens. So what does it mean? It means that for convex lens, focal length is taken positive because it lies on the right side of optical center, as you can clearly see in figure number 2. Figure number 1, while for concave lens, focal length is taken negative as it lies on left side of optical center. Now students, in class 8th, we have also studied linear magnification, which was termed as simply magnification also. And it is denoted by a symbol of small m. So we have earlier done the topic of linear magnification in class 8 in case of plane and spherical mirrors also. So students, how to define linear magnification? The ratio of length of image perpendicular to the principal axis to the length of object O is called linear magnification. What does it mean? It means that the ratio of height of the image perpendicular to the principal axis divided by length of object, which is also perpendicular to the principal axis, and you have to take the sign convention also in consideration. Students, there are two formulas of magnification. First is length of image divided by length of object. You can also say height of image divided by height of object, and it can also be written as ratio of V upon U. V upon U means distance of image from the lens divided by distance of object from the lens. So now students, let us continue further and understand the unit of linear magnification. Since it is ratio of same quantities, therefore linear magnification does not have any unit. Moreover, students, if the image is real and inverted, if the image is real and inverted, it is taken as negative, while if the image is virtual and upright, upright means erect, then magnification is taken as positive. These sign conventions and linear magnification was already discussed. It remains same for the case of lens also. So the value of m can be, students, it can be less than 1, equal to 1, or greater than 1 also, depending on whether the image formed is diminished or it is same as that of object, or it is enlarged as compared to the size of the object. So magnification can have any value that is less than 1, equal to 1, or greater than 1. It depends on whether the size of the image is smaller than or equal to or greater than the size of the object. Students, now we are ready for the numericals. So let us start numericals of exercise 5C, which are given on page number 127 of your physics textbook. Kindly open page number 127 and also open your physics notebook, as you will be doing the numericals along with me. Now let us read numerical number 2, students, first of all. So according to numerical number 2, what do we have? We have that a concave lens forms the image of an object kept at a distance of 20 centimeter in front of it. So first of all, let us draw a rough diagram that you are having a concave lens. So first of all, we will draw a concave lens, and in that concave lens, an object is placed 20 centimeter in front of it. So we will draw an object on the left side of a concave lens such that from optical center, the distance is given to be 20 centimeter. So the distance between object and lens is 20 centimeter. Kept at a distance of 20 centimeter in front of it, at a distance 10 centimeter on the side of the object. So the image, see the question properly. A concave lens forms the image of an object kept at 20 centimeter. Object is kept at 20 centimeter in front of it, and the image is formed at a distance 10 centimeter on the side of the object. Students, we have already learned the ray diagram of concave lens, and the image formed in that case is virtual, erect, and diminished. So what is the nature of the image? Now, if we want to find nature, we cannot directly write down the characteristic of the image. The distance between image and optical center is 10 centimeter. So to find it, we will use the formula of magnification. So students, linear magnification is equal to V by U. Now what is V? Distance between optical center and image. It is on left side or right side? It is on left side. So it is minus 10 divided by object is placed on left side. So minus 20. Minus deducts out with each other such that magnification comes to be equal to half. So students, don't keep the answer in fraction. Kindly calculate it in decimal. So half means 0.5. Now check whether magnification is coming positive or negative. The final answer is positive. Positive means we are having a virtual and erect image. The image is virtual as well erect. Now see the number, the numeric value. Is it less than 1 or greater than 1 or equal to 1? It is less than 1. So less than, if magnification is less than 1, it means the image is diminished. Diminished means smaller in size as compared to the object. So students, to find the nature of the image, you have to find the value of magnification. Now coming to further, find the focal length of the lens. So they are saying that V and U is given. Calculate the focal length. So students, here I will use the formula of lens formula, 1 by V minus 1 by U equal to 1 by F. Substitute the value of V, 1 by minus 10 minus 1 divided by minus 20 is equal to 1 by F. So solving it further, this becomes minus 1 by 10 plus 1 by 20 equal to 1 by F. Now students, on the left side, first of all, take LCM such that it becomes minus 2 plus 1. That is 1 by F. So solving here, it becomes 1 by F is equal to minus 1 by 20. So what will be F? Minus 20 centimeter. So students, focal length is 20 centimeter only. Negative sign means that the second focus is on left side of the lens. That is the place where the object and image are formed. So students, can we say this, that the object is placed at focal length? See, your u was also minus 20. F is also coming to be minus 20. So in this numerical, the object is placed on optical focus of the concave lens. Let us read numerical number third. Students, in third numerical, the focal length of a convex lens is 25 centimeter. So write down what we are given. Focal length of convex lens is 25 centimeter. Shall I write down here a sign of minus or positive? It is a convex lens, and in case of a convex lens, see, the second focus is on right side. The second focus as given in figure 1 also. So we will take it as plus 25 centimeter, which can also be written as simply 25 centimeter. So students, the question is, at what distance from the optical center of the lens an object should be placed? That means we have to find u. At what distance the object is being placed? That means u. So as to obtain virtual image of twice the size. Virtual image of twice the size. It means that height of image is double of height of object. So how to write down further? Let us find magnification. The formula of magnification is height of image divided by height of object. And height of image can be written as twice of height of object divided by height of object. This cancels out and m comes out to be 2. Students, since, see the last line, the image formed was virtual, I will take it as simply 2 or plus 2. If here instead of virtual it was written to be real, then till here you should have done the same steps, but in your answer you must have written magnification as minus 2. Minus means a real image is formed. So students, in this question, otherwise we are having a positive magnification whose value is 2. Moreover, students, we are having one more relation. Magnification is equal to V by U also. So put the value of M as 2. So if I put the value of M as 2, what do I have? We'll be having V is equal to twice of U. Now, let us substitute these values in your lens formula, that is 1 by V minus 1 by U is equal to 1 by F. So 1 by 2U minus 1 by U is equal to 1 upon 25. From here, you have to find the value of U. Even you can find the value of V also. From the same earlier also, we can find the value of V also. But since the question is to find the distance of the object, so let us take the LCM first. The LCM of 2U and U is, it will be only 2U. Since U is common in both the terms, it will come as it is, while we will take 2, the other term, to be in LCM. So here it is 1 only. What shall I multiply this denominator such that answer should come 2U? I will multiply it with 2. So I will multiply the numerator also with 2. 2 into 1, 2. So 1 minus 2, minus 1 upon 2u is equal to 1 upon 25. Further, find the value of u, students, yourself. See what is it coming to be. So cross multiplying each other, I'll get minus 25 is equal to 2u, and then this 2 is getting multiplied on left side. So it will come in denominator. So if you cancel it out, half of 25 is 12.5 centimeter. Why centimeter? Since the distances in the question was given to be in centimeter. So minus 12.5 centimeter. The sign minus means the object is placed on the left side of the lens. So the value of u is minus 12.5 centimeter. It means that object is placed on left side of optical center at a distance of 12.5 centimeter. So the object in this question, see, what does it mean? See the question first of all, students. Now, if we see and draw a diagram, what does it mean? Now, it means that if you are having a convex lens, whose focal length is how much? 25 centimeters. So, the distance between optical center and the focal lengths are 25 centimeter. That means each distance is 25 centimeter. So here the object is placed at 12.5 centimeter as given in the question. This is your object. So what does it mean? See, if optical center, distance between optical center and focal lengths are 25, then the object is placed between optical center and the focal length. That means here, this is the last case drawn in convex lens. You will be having a virtual, erect and magnified image. So students, now let us move to question number 4. So students, question number 4. Read the question. What are they asking? See, where should be an object be placed? So where should be an object be placed means find u in front of convex lens of focal length 0.12 meter. Since it is a convex lens, take focal length as positive. To obtain a real image of size 3 times the size of the object. So height of image is thrice of height of object. So students, magnification is hi divided by thrice of height of object, which comes out to be, sorry, this is height of object. Put hi as 3ho divided by ho. Cancel that out. Now the catch is here. It is a real image. So what you have to do? You put a sign of minus here and write down why you are putting minus. Since the image is real. Then put the value of m as v divided by u. So if we put v divided by u, which is equal to 3, then see what will occur. This is equal to minus 3. Then what shall we do? Can I say that v is equal to minus 3u? So now after doing it, put the value in your lens formula. Put v as minus 3u. Students. Now students, we are doing question number 5th. Since question number 4th will be solved easily for you. So now question number 5th. It is a very important question. So how we will do it? An illuminated object lies at a distance 1 meter from a screen. So if you are having an illuminating object, means like a candle, or you can have an electric bulb. So this bulb, any object, is placed at a distance of 1 meter from the screen. Screen is the place where your image is formed. So the distance between the object and the screen is 1 meter. So the question is, a convex lens is placed to form an image of the object. So this is a convex lens. A convex lens is placed to form an image of the object on a screen placed at a distance of 75 centimeter from the lens. So the distance between the screen and the lens is 75 centimeter. So students, 1 meter means 100 centimeter. And if this distance between optical center and screen is 75 centimeter, then the distance between object and optical center should be 100 minus 75 centimeter. That comes out to be 25 centimeter. So 25 centimeter is U, while 75 centimeter is V. So we can say, students, that U is minus 25 since the object was on left side, while V is plus 75 since the screen was on right side. Now students, use the formula of lens to find your answer for focal length, and similarly use the formula of magnification where you will put V as plus 75 and U as minus 25. So you'll get your answers for focal length as well as magnification. Similarly, now coming to question number 6. A lens forms the image of an object placed at a distance of 15 centimeter from it at a distance of 60 centimeter in front of it. See, there is a lens. We don't know the name of the lens according to the question, but they are saying it forms the image of an object which is placed at a distance of 15 centimeter. So U is minus 15 centimeter, done. At a distance of 60 centimeter in front of it. If you are having any lens, if the object is here in front of a lens, image is also in front of a lens. That means V is plus 60 or minus 60? Think everyone. Yes, it is minus 60. Very good. So if we put the lens formula, can we find focal length? Find the value. Search for your answer. It should come to be, F should come to be 20 centimeter. And for further calculation, clarification of the calculation, you can see page number 5 of your PDF. Similarly, find magnification. V by U, that will be minus 60 divided by minus 15. Comes out to be 4. Since it is coming plus 4, so what is the nature? 4 means magnified. And the word plus, it is coming positive. That means image is also virtual and erect. So students, I hope this numerical sign conventions are getting clearer more with the help of these numericals.